Good afternoon, bonjour. My name is Lilian SOUZA. I'm from Brazil. I am professor at the Federal Institute of Minas Gerais. Grande École de l'État de Minas Gerais, dans la cité de Ouro Preto. This is Arracacha, also called Peruvian carrot, yellow carrot, baroa potato, and mandioquinha salsa. It is very appreciated in Brazil by flavor and texture. Sorry, my English no good. This study is part of my doctoral thesis about Arracacha. My advisors, Fernando Luiz Finger and Caetano Marciano de Souza, Federal University of Viçosa. I studied two types of Arracacha varieties and two types of acid corrective for soil, lime or calcium and magnesium silicate. After harvest, I analyzed the mineral composition of Arracacha to verify if there was difference with the assimilated nutrients of the plant. In the second moment, that I will not show here, I evaluate post-harvest conservation of Arracacha, considering different conditions of culture. Arracacha cultive. The importance of Arracacha. Right market value. The Arracacha presents a right market value because it has a long life cycle and a little shelf time, up to 5 days without refrigeration. Situation in Brazil. Uniform genetic. Small number of clones. Risks of pests and diseases, because mainly bacteria. Erwinia carotovora, mainly Erwinia carotovora. National production. Minas Gerais is the second largest producer because high altitude and mild climate. My objective: evaluate the mineral composition of two varieties or cultivars of Arracacha, lime or calcium and silica and magnesium silicate. Amarela de Carandaí, traditionally cultivated. Rye production. Senador Amaral. Cultivar developed from selection of clones, originate from botanical seeds. Beautiful. Silicon. I used the silicate because silicate is used to soil corrective and plant protection. it also doesn't emit dioxide carbon in the atmosphere. The application of 100 tons of lime releases 44 tons of dioxide carbon in the atmosphere. Silicon protector plant. Resistance, the plant's cell wall. Benefits for the environment. Decreases the use of insecticides and the fungicides. No negative effect on natural enemies of pests. Materials and methods. 2 varieties, Senador Amaral and the Amarela de Carandaí. 2 types, acid corrective, lime, silicate. Agrosilício, trademark. Long life cycle, 9 months. Agrosilício have silicon, calcium, and magnesium. Percentage, calcium percentage, agrosilício and lime, approximated. Magnesium, approximated. Treatments. Treatment 1, lime, 1,000. Treatment 2, agrosilício, same dosage. Because the same dosage, agrosilício is more soluble at that lime. Treatment 3, agrosilício at double dosage. To verify if it would have high silicon absorption of Arracacha, I analyzed the following nutrients: silicon, calcium, magnesium, phosphorus, boron, nitrogênio, and potassium. Procedure. Results. The most important results observed were silicon and magnesium. Silicon only leaves and the roots silicon. Others nutrients only roots. Okay? Leaves. Amarela de Carandaí, Senador Amaral. There was significant interaction of cultivar versus treatment. In treatment 1 and 2, the cultivar Amarela de Carandaí didn't have interaction in the silicon absorption. Treatment 3, significant interaction. This confirms the hypothesis that in Arracacha, only with increasing silicon in external solution is that there were significant changes in silicon concentration in the plant. Roots. Amarela de Carandaí and Senador Amaral. The silicon concentration in Amarela de Carandaí in the roads didn't make significant difference between treatment 1 and treatment 2. Treatment 3, there was significant difference uptaking in roads, over twice observed in treatment 2. Calcium. There was no significant interaction between cultivar and treatments. In treatment 3, I hoped that calcium increased because agrosilício, double dosage, has same approximate percentage calcium and lime. On the explication for this, the calcium is transported unidirectionally from the roads to the shoots, and the possible accumulation of this nutrient by excess absorption would be in the shoot. Magnesium. Treatment 2 was effective in Amarela de Carandaí to increase the magnesium content in the roads. This can be the influence of supply silicate, raising the soil pH values closer to the optimal pH for absorption de magnesium. In Amarela de Carandaí, cultivar Senador Amaral, red, no variation between treatments. Potassium. The use of calcium and magnesium silicate in treatment 3, compared to the lime. The absorption in potassium cultivar of Amarela de Carandaí increased with the use of calcium silicate and magnesium treatment 3 compared to the lime. For the cultivar Senador Amaral, the lime had more effect. Boron. In Amarela de Carandaí, there was no influence of the treatment. Senador Amaral, trait of application of agrosilício were more effective in increasing of absorption of the application. The cultivars Amarela de Carandaí and Senador Amaral presented variation in treatment 2. Nitrogen. There was no significant difference between cultivars. Phosphorus. The cultivar Senador Amaral had significant variation for treatment 2, double dosage, in relation to Amarela de Carandaí. There was no significant interaction with the treatments. Conclusions. The results point to different absorption capacity of nutrients between cultivars of the same species. Most likely it is genetic characteristic of the cultivar. I need to study each cultivar, each species. Silicon. The cultivar amarela de Carandaí and Senador Amaral can be considered intermediate species in the accumulation of the silicon. It is important. Soil plant protection, corrective, acid corrective, the increase in external concentration of silicon promoted the concentration of silicon in the shoots and the root parts, which might be beneficial for post-harvest preservation. In agriculture, the substitution of lime for agrosilicio is considered a measure which reduces the emission of dioxide of carbon. The silicon absorption can become an integral part of an breeding program to protect plants against environment stress. In economic aspects, the cost-benefit ratio for the use of the calcium silicate must be analyzed. It is possible the replacement of the lime by magnesium and the calcium silicate from slag steel to the cultivation of Arracacha. Thanks.
You say silicate applications have an impact on pests and disease. Have you seen some difference with the applications of silicate on pests and disease?
I studied post-harvest conservation. That I will not show here. I can verify silicon in double dosage in Arracacha had efficient equality calcium. Lime. Double dosage. In same dosage, in Arracacha, no efficient. Other species, other plants, silicon can efficient. Okay? Other question? No? Thanks.